Today's feature topic sits underneath the entire AI boom, the cooling and thermal supply chain. It's the part of the data center almost nobody talks about, yet it has quietly become one of the biggest bottlenecks and one of the biggest opportunities in the whole stack. Here's how I'll run the next 15 minutes. First, why heat suddenly became the limiting factor. Then we'll follow the heat from the chip all the way to the grid. And only then will I start naming names, the specific companies that make this ecosystem work, and exactly who sells to whom. So hold one question in your mind. Who are the players? We'll get there. Welcome to Introcorp by S, a recurring series for the feature topics, where every claim is backed by real data and told with craft. This episode, we follow the heat. As AI chips push past what air can cool, an entire supply chain has sprung up to keep them running, from the silicon all the way to the grid. We'll trace who builds it, who sells to whom, and why cooling just became the industry's hottest bottleneck. Before we meet anyone, let's set the stage. For years, cooling was an afterthought. Watch how three simple forces, chip power, rack density, and plain physics, turned it into the single biggest constraint on AI. Let's start with why cooling suddenly became a first-order problem. For decades, cooling was an afterthought, fans and air handling. That era is over. Look at the numbers. Flagship AI chips now exceed 1,000 watts of thermal design power in a single package. That's past the practical limit of what air can carry away. Stack those chips into a rack and you approach 1 megawatt per rack. The result is a step change in adoption. Liquid cooling penetration in AI data centers jumps from around 14% in 2024 to over 30% in 2025, according to TrendForce. And it's driven by a new generation of accelerators that are liquid-ready by design, more than 80% of this year's high-end shipments. So the headline is simple. The heat problem forced a technology transition, and that transition is happening in a single product cycle. This slide frames the actual technology shift. On the left, air cooling. It's effective to roughly 20 to 30 kilowatts per rack, and it still has a role, networking, storage, and lower density zones. But it hits a wall above about 50 kilowatts, and every extra bit of airflow costs fan power, energy, and floor space. On the right, liquid cooling, the new baseline. Three things to know. First, direct-to-chip cold plates. A copper microchannel plate sits right on the processor and carries heat away in fluid. Second, CDUs and manifolds move that heat from the rack out to the facility loop. Third, immersion. Full submersion is emerging for the very highest densities. The key point? Liquid is the only path to the highest power accelerators at scale. This isn't a preference, it's a physics requirement. Now, the market context, so we understand the money at stake. The global data center liquid cooling market is roughly $6.7 billion in 2025, growing to about $8.2 billion in 2026, and forecast to reach nearly $30 billion by 2033. That's Grandview Research. That's a compound growth rate of about 20% a year, sustained into the 2030s, essentially a fourfold expansion. And watch where the smart money is moving. In a single week in November 2025, 3 strategic buyers each acquired a cooling platform. When that happens all at once, it tells you the thermal layer has gone from niche component to core infrastructure. A chip-to-grid capital cycle is underway. I'll name those buyers a little later. To see where each supplier eventually fits, you first have to see the thermal stack, the journey heat takes from the chip to the grid. Each link is its own supplier market. It starts at the die, flagship AI silicon, the heat source. That heat hits a cold plate, a copper plate bonded to the chip. From there, manifolds and tubing distribute coolant across the rack. Then the CDU, the coolant distribution unit, exchanges heat between the rack and the facility. Finally, the facility and grid layer, chillers, heat rejection, and power. The takeaway at the bottom, cold plates and CDUs are the two highest value, fastest growing links. A specialized set of suppliers has taken the lead there, and on the next slide, I'll finally name them and show you exactly who they sell to. Pause here for a beat. For the last 5 slides, I've deliberately kept the names off the screen. I wanted you to feel the physics and the market forces first. Now we flip that. From here on, I'll name every player and show you exactly who buys the cooling, from the silicon all the way to the operators who run the racks. Here's the map. This is the heart of the briefing, and the moment I've been holding back. Here's the relationship map. Who actually buys the cooling across the entire value chain? Start on the left. These are the thermal suppliers, the sellers. On cold plates, AVC, Auras, Cooler Master, and Motivair. On CDUs and facility systems, Delta, Boyd, Vertiv, CoolIT, and Eaton. Now watch how their cooling flows up through 4 tiers of buyers. Tier 1, the chip platforms, NVIDIA, AMD, and Intel. They set the thermal spec every vendor must qualify against. Tier 2, the server ODMs, Foxconn, Quanta, Wiwynn, Supermicro, Dell, and HPE, who integrate cold plates and CDUs into finished racks. Foxconn, for instance, is the exclusive builder of the flagship NVL72 rack. Tier 3, the hyperscalers, Google, Microsoft, AWS, and Meta. They don't just deploy at scale, they increasingly co-design their own cooling. Google's in-house CDU spec, Microsoft's cooling sidekick, and Amazon's own heat exchanger all pull directly on this same supplier base. Tier 4, the co-location and neo-cloud operators, Equinix, Digital Realty, and CoreWeave, who run these high-density facilities for everyone else. The single most important insight, the same handful of thermal specialists sell into every one of these tiers, and the higher up the chain they go, the more value they capture per rack. That shared supplier base is what shapes who wins, and it's what we'll unpack in the deep dives that follow. You've seen the whole map. Now let's zoom in, platform by platform. We'll start with the biggest gravity well in the industry. Then look at the challengers opening new sockets for the very same suppliers. Let's go deeper on NVIDIA, because it's the gravity well of this entire supply chain. The GB200 and GB300 NVL72 are rack-scale Blackwell systems that are liquid-cooled by design. Qualifying onto NVIDIA's recommended vendor list is now the single biggest prize in thermal. NVIDIA publishes the MGX reference design and specifies the thermal interface, and vendors build to it. Because Blackwell is over 80% of high-end shipments, that spec effectively sets the industry standard. Look at the partners. AVC, copper microchannel cold plates, a core NVL72 supplier. Auras, cold plates and loops, and its revenue jumped nearly 48% in 2025 on this demand. CoolIT, an NVIDIA partner network member with its NA2 cold plate loop built for GB200, backed by over 100 patents. Boyd, which has shipped more than 5 million cold plates and whose ROL2300 CDU cools 10 plus NVL72 racks. And Delta, Eaton, and LITEON rounding out CDUs, rack cooling, and power. The message: winning NVIDIA is transformational for any thermal supplier. NVIDIA isn't the only game. AMD and Intel are the challenger platforms, and they matter because they open a second and third socket for the same suppliers. AMD's Instinct MI300 and MI350, including the MI355X, come in both liquid and air-cooled versions. Motivair builds dynamic cold plates engineered specifically for those parts. Supermicro and AMAX deliver the rack scale systems. And critically, the same Taiwan cold plate makers, AVC, Auras, Cooler Master, serve AMD too. Intel's biggest thermal role is as the x86 host CPU sitting alongside the GPUs in nearly every AI server. Those Xeon head nodes need cold plates of their own. Lower density Intel zones keep air cooling relevant, and the facility layer is cooled by Vertiv, Delta, and Eaton. So the strategic point. For the thermal specialists, multi-platform qualification is the growth story. The more sockets they're designed into, the more resilient their business. We've talked about the platforms that buy the cooling. Now let's meet the companies that actually build it. The specialists who turn decades of thermal engineering into the backbone of AI infrastructure. Now, let's introduce the players. Starting with Taiwan's thermal champions, because this is where the supply base is concentrated. These companies converted decades of PC and server cooling know-how into the AI cold plate and CDU market. Auras Technology, a leading thermal module maker, and a standout financially with a 47.6% revenue jump in 2025. AVC, Asia Vital Components, Kaohsiung-based, whose copper microchannel cold plates have made it an essential AI cooling partner with strong 2026 growth. Cooler Master, a broad thermal portfolio spanning data center, telecom, and automotive. Delta Electronics, the power and cooling giant, with its GoCool 3 MW CDU and a full grid-to-chip architecture. And MG Cooling, an emerging Taiwan component supplier expanding into the AI cold plate ecosystem. Bottom line, if you're sourcing cold plates at scale today, the conversation runs through Taiwan. Beyond Taiwan, here are the global CDU and full stack players, the companies that tend to own the higher facility-facing end of the stack. Boyd, more than 5 million cold plates delivered to hyperscalers, and its ROL 2300 CDU delivers 2.3 megawatts, cooling 10 plus NVL72 racks. It even showcased Google's 2 megawatt CDU at OCP 2025. CoolIT, 24 plus years, over 100 patents, and a core NVIDIA partner. Vertiv, which pivoted from general infrastructure into high-density thermal leadership. Eaton, a validated recommended vendor for GB200 NVL72, expanding through acquisitions. LITEON, integrated power, cabinet, and liquid cooling for GB200 and GB300. And Motivair, high-performance cold plates engineered for AMD's MI300A. The pattern here, these firms compete on CDUs, scale and system integration, while the Taiwan specialists compete on cold plate volume. Together, they form the whole supply chain. So where does all of this leave us? Let's step back. First, who competes where across the stack? And then the handful of shifts that will decide who wins. Let's pull it together with positioning, where each supplier actually plays across the 4 highest value layers: cold plates, manifolds, CDUs, and facility or power. Notice the 2 shapes. The Taiwan specialists, AVC, Auras, Cooler Master, concentrate on cold plates and manifolds. The global players, Delta, Vertiv, Eaton, sit on the CDU and facility side. And a few, like Boyd and CoolIT, reach across cold plates and CDUs both. Full-stack vendors capture the most value per rack, but the specialists win on scale and on qualification. And remember, cold plates and CDUs are the fastest growing, highest margin links in the chain, so that's where the competition is fiercest. And that's the chip-to-grid story of AI cooling. If you found this useful, hit subscribe. This is the feature series on Introcorp by S, where each episode unpacks the companies that quietly shaped the world. I'll see you in the next one.